Hey everyone, welcome to the SDA Skills System Design session by Naga. We were originally planning to have this in person in the Redmond library. Unfortunately, due to the weather and the library closure, we just thought we'll convert it online. So Naga has actually been kind enough to put together sort of a presentation that we'll be using to follow along. And I did post this into multiple forums, so just a quick thing is that if you guys have no idea what SDA Skills is, or if you this is the first time you're joining, then please make sure that you go take a look at www.sdaskills.com, and there's a bunch of ways you can actually engage with us. You should be able to look us up on YouTube. We have a bunch of videos that we generally record our weekly sessions and we post online. And we also have a pretty active Slack group. So if you want an invitation to our Slack group, go to www.sdaskills.com/Slack, and it will take you to the sign-up process, and you should be able to join. Our group is about 2,700 people or so. We are reasonably active. Feel free to join us. And we are a little selfish in the sense that we are actually a mostly in-person meetup group in Seattle. So folks outside Seattle or East Side, just too bad. Unfortunately, we are not there yet. We do have monthly online sessions that is run under the San Francisco umbrella at this point. So there are a bunch of ways to engage. Join the Slack. I think that's probably the best way for you to get going. With that, I will hand off the mic to Naga for the session. Thank you so much.
Thank you for introducing Vivek. So yeah, welcome everyone. So this is my first session on system design, and since this is the first of series in this year, I wanted to cover like some of the fundamental concepts that are covered in system design. So as we go through let me switch to the next slide. So as we go through each of the concepts, I encourage you guys to stop. Like if you want to add on something, feel free to stop. Otherwise, just like mute yourself and try to listen through. And if you want to stop, like you can always stop me and ask any questions. And yeah, so yeah, as you all can see, this is the agenda of high-level topics that I want to cover. So we'll start with like how we want to prepare at a high level for system design interviews, like a study strategy basically, and we'll look at the key terms that are used in system design interviews, key concepts, and so we'll look at the CAP theorem and what DNS, CDNs are and what they're used for, and the load balancers. Guys, if you don't want to speak, like please mute yourself so that can listen. Load balancers, like we'll also go through reverse proxy databases, how to scale the databases and different caching mechanisms, and a small comparison of TCP and UDP, and then like we'll have some time if left for questions and any like future topics that we all want to learn next time. So I have like this is about like 36 slides. We'll try to see how much we can cover in this 2 hours. I know it may be tough, but let's see what best we can do. In case if we can't finish today, like I'm happy to cover this in some other session. Okay, with that, like we will move on to the next slide, which is like the study strategy for the system design interviews. So in general, like with the system design, like how companies want to they just want to throw some open-ended questions and see how you are responding to that and how you are approaching. So since this is unstructured, like each one might like have their own strategy or something, but at a high level, I feel like this slide which shows the like the approach works better for most. So if you have like crunch in time and you have to learn like for the aim for the breadth, so you have to learn as many as concepts as possible at a fundamental, like a very basic level, what they are for and what they used to do. And if you get some more time, try to dig deeper in each of those concepts and see what best you can learn. And if you have long time to prepare for the interviews, then you can, like in each of those topics, you can go as much as depth as possible. And like in the next slide, I will also show what going depth means, like. And since this is like more of system design, and there is also some companies focus on object oriented type of questions, so which I'm not covering today. So most of the topics covered today. So I don't know, I'm hearing some echo.
Proceed. I'm just muting folks.
Okay. So the object-oriented questions we are not covering today, but like some companies tend to focus on that also. Like, and I mean, like we are happy to cover that in some other session. And yeah, I mean, generally the system design interviews are more for like for the experienced engineers, but it's not that they can be thrown out for fresh graduates also. I mean, like they're expected to know at least the minimum version of it. So the more experienced you are, the more rounds, like the more focus would be on the system design. And if you are like architect or lead kind of roles, then like you might be expected to know in depth about each of the system design topics. So let's move on to the next slide. So yeah, it's like accompanying, like it's just trying to state the information like the previous slide in a more better way with the links to the different topics that I'm covering today. And like if you are like in the short mode, like you have to get the system design topics that I'm covering today, like it's also there in this link. You can follow later. And you can also check out some of the company engineering blogs to see what each company and their products are doing. And you can also go through some of the real world architecture if you are having less time, and if you have more time you can go most of it. So similarly, like how we want to approach system engineering question, like there is some tips here. And you can also go through some of the real world architectures, and this is for the object oriented. I have given the links here also, so feel free to go through them like as and when you get time. So with that, let's jump onto the basic concepts or terminology that I wanted to cover. So the
a couple of folks have asked the question, will you be sharing the slides? I just said that we'll be sharing the slides after the presentation. They're not uploaded in any meaningful form, but I will upload after the session and share a link as a part of the meetup. Thank you.
Okay, yeah, thanks for stopping. I'm not actually following the questions, so yeah, feel free to let me know to stop.
Yeah, go ahead. I will let you know if there are any more questions from the audience.
Okay, so the basic terms, like the first terms and comparison that comes to like in the system design is performance and scalability. So what do we say like when we are saying system is performing well? That means like your system is responding, I mean like faster for a normally like for a single user with the amount of resources it has. And when we say service is scalable, it is proportional to the number of resources that is there. Like if we increase the number of resources, then performance should also increase or with that number of resources. That means that like if you add the resources, you should be able to handle more units of work. So as I put on here, like if you have a performance problem, your system would be slow for a single user. But when we say like you have a scalability issue, then like it works faster for a single user, but it will get slow for a heavy load. So we will be covering like different scalability patterns, like like vertical scaling. As you all know, like there is not a lot to say about that. Like it will be the like if you just increase the machine capacity, like just increase the RAM, storage, everything, then that means like you are doing vertical scaling. But like I'll be covering more aspects of horizontal, like when we say like adding more servers and adding like load balancer, how how the system scales up. So that is like a horizontal. And there is also a caching which helps in this scaling the systems. And with the databases, you have replication and some other strategies. We'll look at all those like in the coming slides. So another basic terms that we should be aware of is latency and throughput. So what do we say like when somebody expects minimum latency for your application? That means like if you are hitting a web page or like hitting an API, it's the time taken to respond for the page to load, or like for your API to respond. That is the latency. So you want to like minimize latency, considering all the network barriers like as much as possible. That's your general goal. And like when we say throughput, like it's basically the number of each actions or results. Like if you're, when we say API, like how it behaves, like when we hit like thousands of requests like per second, is it able to handle those requests? That is what we term as throughput. So it's how many actions you could execute per unit of time. So that unit of time can vary according to the system and the way that you are planning to do, but generally we do this kind of calculations per second. So in general, like you should aim for maximal throughput with acceptable latency. So what users would ideally want the latency to be, and with the maximal throughput, so you are making best use of the system. So another very key terms like in the system design is the consistency and availability, and we also have partition tolerance. And so looking at this, like when we say the system is consistent, what does it mean? Like, so every read that a user is doing, like if you take an API, every read should either return like the most recent write, or it should error out. And similarly, when you say the available, when the system is available, your system should be able to respond for each and every request that it receives. Though like it doesn't give the latest data, it should be able to respond, like success or failure response, or like so ideally it should, like even if your system is not consistent, like it should be able to respond to every request. So that's what we call the system is available. And when we say the system is partition tolerant, it means that like nowadays, like however we prepare, like we all come up with some unexpected failures or network barriers, like or the Wi-Fi or whatever the network breakdowns. So we will have to live with that. So with that being said, like our system should normally be partition tolerant, means that like you should be able to split your system into multiple partitions. So you can get around with this network issues, like though in one area you have network issues, your system would still be up because of other network nodes that you have. So so that's about these three terms, and these terms form the basis for the cap theorem that I'm going to talk about here. So this, so of those three, consistency, availability, and partition tolerant, like we know like the partition tolerant needs to be supported because you cannot control that network issues and all. So since the network is not reliable, so you'll have to always support the partition tolerant. So of the other two, which we cannot, so the other two options that we have is like consistency and availability. So if you want to achieve consistency, you need to sacrifice availability, and vice versa. Like if you want to your system to be available, so I mean like you are not completely sacrificing the consistency, but like you can get around, like your focus of the system should be either consistency and partition tolerance or availability and partition tolerance.
Hey Naga, can you just elaborate what do you mean by like when you say that there's no guarantee that it will contain the most recent information?
So you mean for the availability?
Correct. I think the question from Jyotsna is like, what do you mean by there is no guarantee that you will have the most recent information? Consistency basically.
So is it on the previous slide? Okay.
Correct.
Yeah.
So okay. Yeah. Thanks for asking that.
So what I was saying is, when we know that when even for failure cases, that the system should be able to give some response that the request failed or something like that. But I didn't quite follow when it was mentioned without guarantee. So the response to failure scenario should be guaranteed, right?
So failure, like I mean, like when we say system is available, I think like we need to give response even if it's a failure, and we are not guaranteeing that like when the system is available, you always have the most recent write that he has written. You are getting in the read. So he may be reading some old information which is not up to date. So that's what I meant in this here. Suppose you are so if you have designed your system to be eventually consistent, so you are just making a write and the write hasn't took place, so it's still in the queue and processing, and the user is trying to hit the read again and see if that whatever the update that he did is there or not. So it takes a while for that systems to be updated in the database. So when we follow this asynchronous pattern, like eventual consistency, so at that time you are not guaranteeing your system to respond with the most recent version, right? So it could be the legacy.
Okay.
So it should be a little older version of the information that he may see for a while.
Okay, got it. Thank you.
Okay, hope that clarifies. Yeah. Okay, so let's come back to. So any more questions? Okay, so I hope no, and I'm continuing. So when we say like as I said, like we are left with two options now, either CP or AP. And when we say our system is supporting CP, like I mean like what it indicates is like you are supporting the system to be choosing consistency. That means that every response that you see will have the latest info, or it will result in like error. And CP is a good choice.
Few quick questions. One is, so if you actually support partition tolerance, do you mean that typically you sacrifice consistency? Is that how it works? Or is there a way to achieve partition tolerance and consistency, but then you sacrifice something else?
Yeah, so when I say CP, we are sacrificing availability. We will let the system sacrifice availability that it might not be able to respond for some request because we want consistency as a priority.
Got it. So to answer like SB's question, which was saying that if you support partition tolerance, that's your number one priority, then you have to choose which one you want to sacrifice.
Yeah.
Either consistency or availability.
Or availability. Yes,
you can choose one.
So, but partition tolerance for sure we need to support, because we should be able to have our system tolerant to the network failures. So we need to be able to partition our system so it could respond even if one of the node goes down.
Can you take a step back and explain the partition tolerance and tolerance in specific, because it looks like we have a question on what is tolerance, why is this partitioning is the way to do it. Can you just take a step back and explain that one more time, please?
Yeah, so when we say like why the PT partition tolerance needs to be supported, it's because that like though we are optimistic about networks being reliable, I mean like it is not always the case, right? Like our system, like if you have everything working in a single node, and I mean like if the users are spread over like all over the I mean like world, and if your single system where it's residing, and for some reason like for some natural calamities or some network issues, like if it ends up being not able to respond, I mean like then it's a key thing, right? So if you want either your system to grow or like to be able to support either like being consistent or available, you should be able to partition your system into multiple nodes. So that's one of your key strategies if you are when you are designing a system. So if you design a system which cannot be partitioned, that means that you won't be able to achieve either consistency or availability. So did I make it sense? Like
yep. Keep going.
So that's why I mean like if we want our system to be scalable in the future, like or to be able to support a good consistency or availability, you should have your system to be able to be partitioned. So like if you can't split your system into multiple nodes, then I mean like it's hard that I mean like it's evident that you won't be able to accomplish the other two. So you want to add something? Yeah, tell me.
You said if the system is not having partition tolerance, then we cannot achieve consistency and availability. Is that right?
Yes.
Actually, the partition tolerance will come into picture when we go for distributed system, right? In case if I am supporting with one big server, it's not distributed in the network, then I can achieve consistency and availability, right?
Yes. So when I'm saying systems, yeah, mostly I meant here the distributed systems. Yeah, thanks for clarifying that. I mean, like I assume that. I mean, like so if that confuses enough you, yeah. So when I say the system design, like it's mostly distributed here, because yeah. So
Naga, there is one question from there's one question from Nidhi, which is basically saying, but looks like these days with all the cloud storage and cloud storage design systems, looks like we have kind of somehow conquered the CAP theorem. Like, maybe we can probably support all the three: partitioning, the partition tolerance, consistency, and availability somehow. Can you comment on how that's actually happened and what am I missing?
So when we say, I think my perspective is like, maybe you can also add on, like when we say like we are using cloud, So they are already taking care of this partition tolerance. They have different availability zones. They have different regions for any system that we are using. If we are using any cloud service, it means that they already took care of all this, like all these three. That's what I feel. So they have the different availability zones, like they have the region concept. So the any service that you launch on cloud, any data that you run there, they will not have like though you launch in one of the region or availability zone. I think they will be internally having this all the standards of partition tolerant and all.
Got it. Makes sense. So going back to the first question, right? So it kind of looks like how somehow we are designing systems now which are violating CAP theorem. The CAP theorem is essentially it's still applicable, but the thing that we need to look at is that I think the broad strokes of the CAP theorem is still valid. It's just that we have gotten to a point where we are able to fix some of the challenges and make these things less relevant. Specifically, if you look at things like S3 or DynamoDB or any of the other systems that we've been looking at, they do have they do still follow the same premises. Like in a DynamoDB, the goal is that things are eventually consistent, which means that if you write in one cluster, it does take a little bit of time for it to propagate to the all clusters. So when you do a read from a different cluster, you may not actually get the exact value that you wrote, and that's how the systems actually work. There's a lot more nuances to this, but modern systems have actually taken care of a lot of these things. It's just for us to know whether which vector is actually something that's important for us while we're designing, and which vectors are okay. Specifically, like availability is super important. Obviously, you don't want things to be less available. But when it comes to consistency and partition tolerance, I think you have a little bit of give and take in terms of which ones makes more sense for your specific system. So it's worth thinking about that. Does that make sense?
Yes. Yeah, I think that adds a lot.
There's one more question. There's one more question from Carlos. It's in a traditional master-slave database setup, can we lose the connection with the master node connection and still be partition tolerant? I imagine that in that case, we'll probably want a standby master node in case the primary goes offline. So how does that the partition tolerance work when you have like a master-slave database setup?
So I think my thought on this is that like when we say master-slave, right, and if the master node goes off, I think we would have the logic for the slave to take up the master position, but it takes a while because system might not be available for a while. It's basically the time the slave takes up to the master position. So I think it is partition tolerant in the master slave. That's my
Yep, makes sense.
Is that the idea is that we have master slave, that means we have made it partition tolerant. Now we can choose between consistency and availability. That means master slave means master and slave both should be able to communicate. Now when we say that it is partition, it's when the master could not communicate to slave, but everybody can talk to either master or slave. Suppose there are two clients. One client can talk to the master, one client can talk to the slave. So they both can read. Now master and slave can't communicate. So suppose somebody is updating the master, slave cannot be updated at the same time because that is broken. Okay. Now in that situation probably we can either choose consistency or availability. If we say that we are choosing consistency, that means we are sacrificing availability. What it means is that suppose master and slave are not able to communicate, we say that system is down. We choose availability and give up the consistency, right? So in that case, we say that both are available, but maybe it is not consistent. It will eventually consistent when master and slave again they start communicating. But if they are not able to communicate, that means master and slave might have a different data, and we are choosing availability instead of consistency. So it looks like we can choose any of these two. Most of the time we go for CP or AP and not CA because we can't control partition tolerance. I mean, we can't control network communication. That's why we always kind of talk about either CP or AP.
Is partition tolerance same as fault tolerance? Are those two different concepts?
I think it's, I mean, like fault, I think when you're saying you're only looking in terms of failures, right? Like the system to be able to bear the failures. So that means that you're designing for failures. So, but when I say partition tolerant, it's actually you are in generalized, like either for irrespective of failure scenario, you're talking about the system being partition tolerant.
The system being able to function in case of a partial failure is called partition tolerance. Fault tolerance is basically trying to design a system in case the whole system goes down. Is that the analogy correct?
That sounds like a reasonable analogy, but I.
They are different concepts, right? So let's take a step back. I think the fact that you've introduced the concept of fault tolerance is interesting. So what does fault tolerance mean in general? Fault tolerance is essentially the capability of a system to operate in case something goes wrong, like some aspect of it goes wrong. And it could potentially mean that, like for whatever reason, if you have like a website that is booking tickets, then your fault tolerance is essentially saying that I have a mechanism to somehow either continue the operation or tell the customer that the operation is not possible because of some other issue. So you have a way of actually handling the customer scenario in the case of a system failure happening. So that would be fault tolerance in my opinion. Now, partition tolerance is a very specific subclass of where what you're saying is that your different partitions can actually continue to operate independent of each other, and eventually when the partition is restored, like the partition, when the system is like, when the network partition is actually joined together at a later point of time, the network connectivity is restored, somehow the system is able to figure things out and automatically work and continue from that point forward as a single unified system. So think of like a system where you're trying to do voting, for example. If you are actually voting in one cluster and somebody else is voting in another cluster, that's fine at this point of time. Eventually, all the votes will be tallied together, and all the partitions will get together, and you're pretty much fine as long as there is no challenges. And imagine there's this thing that actually lets you vote only once, right? You should be with a partition system, like a system which has partition tolerance, you might be able to vote in two different partitions with your identity because the partitions don't know about each other at that point of time. But at some point of time, the reconciliation will work and only one of your votes will be considered. And that is possibly based on like a timestamp or something like that. So partition tolerance specifically focuses on that eventuality where you have a bunch of partitions in your system for the sake of availability, in the sense that you have kept identical, like, nodes that are serving identical information, content, or behavior. And the goal of partition tolerance or at least like the goal of partitioning is to make sure that the system is available, and the goal of partition tolerance is to make sure that each of the partitions are self-sufficient in terms of functionality, so that you don't have to rely on some consistent entry to make things work. So these are all different concepts and a tad bit like harder to chomp through, but it just makes sense for you to think about what these things actually mean with examples.
Thank you, Vivek. Yeah.
All right, awesome.
So I think
go ahead,
there are a few more questions. So I'm not saying like PT is only for availability, but when we are saying like we are doing partition, it's to be able to I mean like to be able to system to be consistent or available. That's the main target. So when we say we want the system to partition, it means like it could be for the other two reasons, like here if you say either for consistency or for availability. So it's mainly like your system would respond most likely if you choose availability, and if you choose consistency, it might not respond all the time with success. So basically, like, just to sum up, I mean, like, since we constrain the time, we have a lot to cover. So I would probably continue, and maybe we can even talk offline, like if you can Slack me. So CP is good for normally if you're doing any transaction-based systems where you're expecting some kind of atomic operations. So basically for a transaction-based systems, and availability you will have to choose, like if your business is okay, your system, I mean, like if the writes being not available immediately, and availability needs to be chosen, and even your system needs to respond despite some failures or errors. So with that, like, let's move on to the next topic. So here, like in the CP, we will see what kind of consistency patterns that we have today, like at least like possible. So when we say weak consistency, like after a write, reads may or may not see it, but like the best effort is taken. So the typical systems that follow this are like this memcached. If you're doing even like VoIP or video chat or multiplayer games, they follow this pattern. And when we say system is eventually consistent, we say like after a write, reads will eventually see it, but like it's typically like within milliseconds in the considering the modern systems. And when we say eventually, the data is replicated asynchronously. So the systems, real world systems which follow this pattern is DNS and email. And when we say a strong consistency, like when we write, the next read should be able to see that. So in this case, like if you're having an API to support, like your API would not respond until the write is successfully completed. So here the data would be replicated synchronously. So the examples, real world examples, are file systems and RDBMS, like either the transaction is committed or nothing. That's kind of a thing, right? So they follow this strong consistency. So any questions? I hope this is clear.
Can you briefly explain, what are the mechanisms in the database or any other storage system to achieve strong consistency? Like, how do they do it? How is atomic operation, handled?
Mm-hmm.
Can you explain a bit, the technology behind it?
When we say achieving strong consistency,
right? What are the different atomic mechanisms that we apply to make sure our transaction is strongly consistent? Yeah.
Yeah, I mean, like, to say, like, whenever we use RDBMS, like, we know, like, we want the system. I mean, like, when we commit a transaction, we know the system is doing atomic, right? Like, we are not like waiting or just submitting to RDBMS and proceeding with our way. Like, if so just trying to think which technologies. So
the question, I asked this question because way back when I was doing basic distributed programming in Windows, I see there are APIs that are specifically meant for atomic operation. You provide those APIs the set of tasks that you want to do, and then that will do either all the tasks or none of the tasks. So I was trying to get like an in-depth idea of how RDMS or any other system does that, or a storage component does it. So just a question.
You mean the internals, right?
Right.
Basically, yeah, I think irrespective of the so from what I see, like irrespective of the technology, the general strategy in this atomic operations, like when we say even RDMS or whatever the system follows is, so you will, though you have a set of actions, what we normally do in those set of actions, like we want like everything to be happening in a synchronous way. That is first thing. And if one of the system fails, you should have a mechanism to revert all the previous steps that you have taken. Say like you are taking 10 steps. So what we normally do in this pattern is like you have done 5 steps and the remaining 5 steps are yet to complete, and the 6th one fails. So as long as you have the mechanism to revert the previous 5, I think, and waiting to commit the whole thing that you have done until the 10th step, that kind of high level strategy should work, the system being consistent. So I don't know, like if someone else wants to add something, like Vivek.
So what I just understood was an architectural solution to this problem. Basically, apply a commit and rollback, architecture. Commit all the logs that you have done, log all the commits that you have done, and if for some reason one of the commits does not succeed, roll back. That's an architectural overview of how you would address this problem. I think that does answer my question to some extent. Though I was looking for more system level.
So,
yeah, I think there are some other patterns, good patterns, definitely, because this is age-old RDBMS steps that I might have mentioned. But I think there are some databases nowadays, like which support, apart from RDBMS, I don't know, which support strong consistency. I think it's interesting to look at those architectures to understand. Sorry, I stopped someone from saying something.
Yeah, I was just trying to say about basically there are some of the CS system, basically the system that are not partition tolerant, they will support the strong consistency. So RDBM is one of that, yes, true. And when we are talking about this partition, right, let me spend just a little bit more time because there are a lot of questions around it. So the classic example is what it really happened is that, in the Starbucks, right, you have your Starbucks reward card. So initially when they designed the system, what used to happen is that each Starbucks location, basically if you have a reward amount in your card, right, in your account, it used to store at the centralized server. Now, what used to happen is that a lot of time the connectivity between the store and the centralized server used to go down. So they had to solve this problem because a lot of time customers are not able to use this card, right? So what they did is that, they make their system partition tolerant by doing that. There is one centralized server, and then each store location also have some data regarding your card, regarding the balance that you have. Okay, and when you go and use your card, even though the store is not able to connect the centralized data, they will accept your request. But what that does mean is that if you go to this, suppose that store is lose the connectivity, you have a $25 balance, you use $10, it should be $15. But if the store lose connectivity from the central database, you can immediately go to the next Starbucks between the time when it got updated, and you can still use your $25, because the other system still thinks that you have a balance of $25 before it basically, before it sync up, right? So they choose availability instead of consistency, right? But most of the bank doesn't do that. So so this Starbucks, they really did that because they had a lot of connectivity problem. Most of the bank, your transaction go through all the way, so you can't withdraw money from ATM and then go to the next ATM and still withdraw the same money, because they want to be really consistent. So in that case, they choose CA and they use this high strong consistency system or database.
So yeah, so in another just to add to Bhavesh what he was saying, So from what I feel, like even if you take the latest technology of microservices, like when we want to achieve this strong consistency, you either should have the orchestration based or uh, orchestration based solution which either it will do all of this thing or it will have a mechanism to revert whatever, like if some failure occurs, it will have a mechanism rollback events which will automatically asynchronously kick in to revert. And like as soon as you have a failure, you respond with a failure and you revert. You have a mechanism to asynchronously have some event based triggers to roll back the transactions. So I hope it helps whatever the discussion we had. So let's constrain the time. Let's move on to the next one. So here I want to cover the availability patterns. So two of the main patterns that we have is failure and replication. We will look at the failure methods first. So the two famous failure methods are like active passive, or it's also called master slave, and active active, and it's also called master master. So when we say a master slave or active passive, what it means that the two systems will have the regular heartbeat sent between master and slave. And if one of the if we see like the heartbeat is interrupted, it assumes that the active might have went down, so the passive will take some time, take over that active server IP address and resume the service. So the downtime is basically determined based on the strategy, like whether you have the slave running in the hot standby, that means it can quickly resume the operation, or if it's in the cold standby, it will have some time to start up and be ready for taking over. So that's about this general master slave failure strategy. So the idea is that only the active handles the traffic at any time. And the next one is master master. So here it means that the both are managing the traffic, and if your servers are really public facing, then the DNS server would need to have the IP addresses of both. If it's internal, then your application logic will need to have a logic to send the request to both evenly. So some of the disadvantages of this failure thing is there could be some potential loss of data when your master or active goes down before some data that it has got is not yet replicated to the other passive system. And we also have the similar replication like master slave or master master to deal with availability. So, but we will look this when we are we will revisit this when we are visiting the databases, because it's the same topic even considering from the databases. So with that, like, any questions so far? Okay, so let me move on to this. Like, this is I just wanted to give a general sense of what a typical architecture might look like. So this is not an architecture of any like a real world application. Like in general, like how it would be for any system. Like it, depending on the requirements, these components might vary. But in general, I wanted to touch upon some of the components mentioned here. Like if you see, the client talks to DNS, gets IP, and it also has CDN. We will also look at load balancers and the web servers here. And if you see, it has a read API separately, write separately, and there are write async patterns which happens through like the it goes through a queue, worker service, and it would be either updated to the SQL databases, and for the regular read write talks to the SQL databases. And if you see what patterns we have for the SQL databases to scale, like, so at a high level, this depicts the components that I am going to talk about even in the coming slides. So that's why I just wanted to give this a high level picture of where each of the component fits in. And here I mentioned something about object store. That's I don't know if everyone knows what an object store is. So since I don't have that in any of the coming slides, I'll talk about that now only. So when we say an object store, it is it stores like the kind of the file systems only, but it has advantages over the file system. Like if you have some large files or log files, then like they're I mean like very huge files, if you want to store and be accessible or even download some executable like or softwares, I think object store is a good way to store that, because object stores have a flat file system, like instead of the hierarchical regular file systems that we have. So any object that you want to access from that, they can be accessible over REST APIs. Most object stores today support that, and it only gets that piece of object that you are looking for. So they are very optimal in supporting those long files or big files, or whenever you're dealing with those kind of objects. So let's step on to the first component, which is DNS. Let me see if there are any questions, quick questions. Is S3 considered an object store? I think so, because because it supports all kind of files, or like even if you want to have a static website, you can host in S3. So it is storing that objects, like I mean like the files as an objects, and it's responding over the web. So I think it has yes. I don't know. Let's see if there is any other question.
Naga, the object store is totally different concept from database, or a database can act as this object store?
Yeah, the databases are not good at handling the large objects. If you have a very huge blob, like all it stores is just store as a binary content. That's what I think most databases do, just as a blobs. But they are not very effective way to store. I think the way object store deals is like even those big files or large objects, like it splits up into the small blocks as such, and it stores them flat so that like they can be able to reach based on some key or index directly. So it doesn't go like in a tree like fashion. So they're like the flat structures, so which are optimal, and they serve these objects over the REST APIs. So in the today's world.
Okay. So the files should be really huge, right? In case, for example, in applicant tracking system, can we put resume PDF files into this object store, or that may be small?
Resumes, I think they are not so big, but still I think okay. Yeah, object store I think is a good place to be able to respond, right? Like if the object store supports like a REST APIs, I think I think even the resumes can be put in object stores since they're like the docs.
Okay. Yeah, thanks.
Mm-hmm. So yeah, it can store files of any size. I create that, Chai. So yeah, So considering the time, I might not go through all the questions. So please stop me if you want to talk about something. So just a quick summary of what a DNS is. I'm not going in depth because it has a lot, and how it internally protocols and how it works is. So in general, like when we hit the web browser and type some domain name like google.com or microsoft.com, what it does is like our web browser or like talks to the internet service provider, and if that internet service provider doesn't have, maybe for the first time that you hit that website, it talks to its root DNS server to see if it has. So for the first time, it goes to the root DNS server of the like the actual owner, and in the next time each of the signs will actually cache. If you see here, each of the DNS server has a capability to cache those IPs, and like when you define like your website normally in if you are I think the people who might have launched their own website might have an idea. So these are the records that you normally configure. Like the first thing is the DNS server names which your website is hosted, and if you have a mail supporting that a domain name that you are using, you will specify in the CMX record. And this is the actual site name. Like if you take Google, you point to some IP address, and this is an alternative names. Like instead of google.com, you can also say www.google.com. And similarly, if you want to say test.google.com, you can also give that in the CNAME, like some alternative names for which you want to use this DNS server for. And the startup authority is the record which describes where your site or domain is hosted, and that's a primary server name. And this TTL is what like which says how much time each of the DNS server is actually caching. So as I said, like here each server caches IP address mapping, domain to IP address mapping, and for the first time it goes all the way to the SOA, startup authority, who is owning that domain. And so all that path, there could be more here, like in this example it just shows 3 paths, but like in reality it could reach to like 5 or 10 different DNS paths to reach to the SOA. So, and in the path, whoever this ISP or the intermediate DNS servers are reaching, each of them will cache this IP to domain mapping until this TTL record. So that is defined by the whoever is owning the domain. So I think typically it will be an hour or a day, depending on how. Like if you are not keen on changing the IPs, most likely they might keep for longer. But if you want to keep rotating the IPs and all, then it might be set to a lower value.
So one quick question. Sorry to interrupt. Actually, through DNS server, we are trying to get the right IP address for the domain name I typed. But how it is reaching the DNS server? DNS server also may be more than one, right? Because what?
Correct.
How it is
it can have more
server?
than one.
Yeah. When I am typing something, how it is reaching the right DNS server? Maybe help me to understand that.
So normally it goes to this our IP, right? Each of the suppose like if you are using Xfinity or like that ISP, wherever it's hosted, it goes to that to see if it already has. If it doesn't have for the first time, it reaches to the next DNS server, so which it will have as a parent. So there will be some path in the network actually. So like each DNS server will have one or several masters associated to that. So like this IP could our ISP, when we say .com, it could reach to one DNS server, or when we say .edu, it can have different other masters. So, or when we say .government, it can go to some other master. So each of those DNS servers in the path will have several masters, and it will attempt to reach one of the master related to this, like which might better serve this, which is more likely to have this IP. So I think based on some DNS, I mean like they have some logic when it and so it will eventually hit the server which will have this. So in this case, if you are hosting some domain in the Amazon Web Service, and like in the path somewhere it would go and hit the actual SOA, which is Amazon Web Service DNS in the end.
Okay. If my so my understanding, so the internet provider itself will be maintaining this DNS server, is that right? So if I am using Xfinity internet, then Xfinity will maintain.
They will have their immediate masters. They will have the immediate masters, and they will not. Those immediate masters might not have your IP yet. So when the request goes to that master, it will check whether it has. If not, it will continue to go to its own master chain.
Okay.
So like that, it will keep going until it hits this SOA. So I think, yeah, as I said, this is just a summary. I mean, like there is a lot if you want to. I mean, like this is just a high-level insight, right? If we want to go in depth about DNS, there is a lot to cover, and maybe we can plan sometime later this year. So, and so some of the key domains which many of you guys know, I just wanted to refresh. So when we say like the different domains, when I say root domain, it's fully qualified domain name which resolves to an IP address most likely. So, and this actually ends with a period. When somebody says a root domain, it ends with a period. And I mean, like this could be one small example. And when I say it's a top level domain, like it means that it's a .com or .org. Like com is for commercial organizations, org for non-profit, and this is for military, specialized government. So, and gov for government, edu for educational institutions, and net for networks, and for all the 2 letters for like country codes. And there are some more specialized top level domains nowadays. I mean, like this is just at a high level, the important ones. And this second level domain is actually the site name that you want to give. If you are launching your own site, you can give the second level domain as the exact name that you want it to be. And yeah, so this is the actual name which we are saying in the website. And when I say subdomain, it's a sub branch, like within your company, if you want to host docs or some department, if you like, it could be anything. Like, so here example.microsoft.com docs. This is kind of a second domain. This is in the DNS tree, it falls under this above second level domain. And you can also have this host or resource names, like if you, like in the path within the organization, if you want to resolve the individual hosts or specific type of resources, like maybe if you have some resource which is holding only the documents or PDFs or videos, you can have that that name, resource name mentioned here, and that could add up to your the full qualified domain name. Yeah, so yeah, I was just trying to see root domain. Yeah, top level is the .com or something. When I say
Yeah, can you just walk
root
through the hierarchy one more time? Like, when you say example.microsoft.com, what is the root domain?
Okay, just a minute. So this one, example.microsoft.com. So when I say like this could be root domain, but if you end it with a dot, if it ends with a dot, then it means that it's a fully qualified domain name, and it should resolve with an IP address. This subdomain or even second level domain could be root domains as long as it ends with a period and as long as they resolve to an IP address.
Got it. Okay. I think the concept of like what is a domain name versus what is a root domain is being conflated here. So if you were to register, like for example, for SDE skills, we have registered sdeskills.com, and that is essentially the and I used to, in my head, I used to think that was a root domain, but that is essentially the domain name that I've registered, which is the
yes, correct. We could have something. Yeah, correct. It's a variable length name. Yes, correct.
And I can create any subdomain to it, like foo.sdskills.com, bar.sdskills.com, no issues on that one. And I have to just set up my name server to return the right IP addresses or CNAMEs as appropriate. It will be a record or a CNAME record for each of those, and that's about it. Makes sense. So does that answer your question? Yes. Kumar had a question. I think I also got confused about what exactly a root actually means. A root essentially is what you're saying is a fully qualified domain name that ends with a period. So it could be A.B.C.D or whatever, as many subdomains as possible, but it ends with a dot again.
Yes, correct. So even any of this second level subdomain or resource name could be a root domain, provided they end with a period, and as long as they resolve to an IP address, they should be good.
Perfect.
So I hope that answers, and I will continue on to the next topic, which is CDN. So yeah, I hope many of you might come across, or like if not, I just wanted to refresh what a CDN is. The CDN, as like the name, the content delivery networks, it's mostly like nowadays it's on the cloud, and the main purpose of CDNs is to serve content close to the user. If you have some user sitting in India, and if you like, if you want to serve content to them, like if your server is in United States, it takes a while for the network to support that, right? If you have a CDN, so they will have a node, like the CDN cluster network within the India, so those files can get to the person whoever is requesting it quickly. So they are actually good at hosting all the static files. So your servers do not have to serve the request any of the static content. You can just host them in CDN. And though I said CDN is mainly serves the static content close to the user, some CDNs like Amazon CloudFront also has the capability to support dynamic content. So you should be able to, if you have such need, you can also leverage those dynamic CDNs. So the main idea of having a CDN is to serve the content as close to the user as possible, so the latency is low for downloading files, photos or videos, or even like static files like JavaScript or HTML files. And we have two types of CDNs, which are like push CDNs or pull CDNs, and we will see what those are. So when I say push CDN, so it means that like it receives the content from your server. So you need to take the responsibility of uploading all the latest videos or files that you are hosting in CDN, and you should take the responsibility of uploading them to the CDN. So it's basically what you have in your application or system is like when you use push CDN, you will always have URL point to the CDNs, and you normally take the responsibility on your behalf to have the latest files present in the CDN. So this normally works well if your website is not changing very frequently. That means like once in a time or sometime, because so you can always go and directly upload and have them in push CDN. So that's where this push CDN works. And for the pull CDN, this basically is used for large sites where your content is frequently changed, and as the name suggests, like it pulls the content from your server. Here also you'll have the URLs always point to the CDN, but for the first time the request goes to the pull CDN, it will not have the content. So it will connect to your server, and your server will have all the content at any point of time. And the CDN, when it gets the first user request, it pulls the content from your server, and from the next time it will serve as a faster. So that means like for the first time when user hits the pull CDN, since the files won't be there, it takes a while to respond. It will be slow for the first request, but the subsequent will, as soon as the CDN caches it, the subsequent request will be faster. So this works well with heavy user traffic. So that means your content is getting changed, and so this approach actually needs to have a mechanism, like you should have a mechanism to CDN to point to your server so it can pull content as and when they see it. I see there are some questions. Let's see. It's content delivery network.
Yeah, one question was essentially, can you shed some light on how the request is routed from the client to the DNS to a CDN? Like, how does that work?
So I think this DNS servers will also have the CDNs for it, or alternatively, like some of the DNS servers, I think today most of them do support. For static content, we can have the I don't think it is on the DNS, but I think some DNS might support it. But it's usually if you have a load balancer or the first entry point to your application, it can have a configuration to go to the CDN, or since the CDNs are mostly the cloud-based solutions, and they will have this replica of where the user IP, the request is coming in. So it actually routes to the CDN location nearest to the user. So I think that's where CDNs are specialized at.
A bunch of questions actually around, do you think services like Netflix actually use CDN to deliver videos to the customer?
They should.
Yeah, they do.
I think maybe for the hot videos they might have.
Yeah, so
maybe like frequently used, or yeah, go ahead. Somebody wants to add on.
Yeah, so Netflix has a Netflix in US, Netflix in India, Netflix in Australia, and every country would have its own set of content that they want. Okay, so Netflix actually hosts that particular content on. I mean, Netflix would want the content which is closer to Australia to be in Australia and not be residing in the US. That way, it would be faster for the Australian users to access the content for the from the Australian CDN. So Netflix, Amazon Prime, all of these, they do use the CDN extensively for that. I mean, the content needs to be closer to the user where it is.
Yes, and maybe like with the same context, like if I request some content which is more relevant to Australia, and if I'm in United States, so I think for the first time, I think it could be slow. I mean, like for pulling that video to local CDN, and maybe for the subsequent reads, it will be faster, right?
Yeah, Naga, actually, I like to add one more thing. For Netflix and all, they have a smart logic or algorithm. They try to predict the content what user going to look. On previous day itself, they cache everything actually. Most of the videos they try to cache in the local server
CDN.
itself. Yeah.
Server. Okay.
Yeah, Netflix has that much smart logic. Like they try to predict the user what they are going to view, and that much smart logic, and they try to cache everything in the previous day itself. I mean, it's previous day night, something like that. I read that in somewhere. Yeah.
Yeah, actually, so with the link that I am sharing, I think I'm sure it has a Netflix architecture. We can probably deep dive, like when we start practicing some system design questions, we can obviously have the forum to talk about different aspects of that. So since I just wanted to introduce CDNs, I'm not going in depth here. So let's go at a high level observation, like what CDN is used for. That's a general idea. If somebody, I mean, like in a system design interview, you should not end up saying, I don't know what CDN is for or something like that.
Yeah.
So,
one thing to add. So, I mean, CDN works on very simple principle, right? What happens is that in your website, suppose you are referring to a static content, basically you give CDN URL, CDN server URL, okay? And that's a single URL for all the, I mean, entire your website in all the area use the same URL. Now,
yes, correct.
Once it is that URL, now it is CDNs. They provide this service where they basically redirect it to, as you mentioned, right? They cached in the all area based on the IP from where the request is coming. They basically redirect that request to the local storage, and from that the content comes. So it basically offload your service to deliver this static content. Basically, you reduce that traffic because anyway it is static. You are not adding any value. And then user will have a good experience because that CDNs are designed to handle this, to deliver content faster based on the location and other stuff. So this is how as simple as it works. You can upload it, you use that URL, and then it's all CDN business to redirect and deliver it fastest manner.
Yes, correct. So yeah, somebody was asking about the object store, and I don't know S3. I don't know, but from what I say, like even S3 has a similar file system. It can serve the static content, but I think CDNs is pretty closer than it could be faster than what an S3 might offer. I don't know how Amazon internally optimizes S3 for static content. Does it internally convert to CDN or not? But since the CDN concept is having the static content close to the user, I think it's whenever we say static content is a good candidate that we need to use CDN. So somebody is saying, is CDN also a kind of some web server? Yeah, maybe we can say, but it which serves only a static content. Specialized server maybe. So the next important concept that we want to look in is the load balancers. So how normally typical load balancers work? So it's just depicted in this. Like you have a set of workers which are, it could be the web servers or application servers or the databases. So this same principle, wherever you want to use the load balancer, like it can be used. So if you to route to the different web servers, to the different application servers, or to the different databases. So its main job is pick a request, route it to one of the nodes. That's the main job of the load balancer. And how it picks up each request and distributes the request to the nodes in the pool could be based on one of these strategies. It could be random or round robin basis or the least busy, and whichever the server is least busy, for that it can forward. It could be based on some session information or cookie information based on the request, or based on some request parameters, which could be in the header or body or whatever. And the job of is it like as soon as it picks up as a node and routes to one of the worker nodes, and it waits for the response and just sends the response back to the client. So the important thing to note down is, like, when we use load balancers, we only specify load balancers IP to the clients, and clients are not aware of how many servers you have and how many worker nodes we are using to serve the request. So all they know is they're talking to this load balancer system. So, and we'll be providing them with our load balancer IPs. So if we have our site or something like where you are using load balancer, you typically give this as a first IP for your domain names. So the general high-level benefits of having a load balancer: it prevents a request from going to unhealthy servers, prevents overloading resources, it helps eliminate any single point of failure, like if you have one server always responding, and if that fails, then you don't have any mechanism to respond. But in this load balancer system, it knows that one system is down, so it really distributes the other requests to all the other nodes that are up and serving the request. And one of the interesting functionality where we also can use load balancer is, suppose like if your system, like if your website is HTTPS based and you have this SSL certificates, like each of the servers you have in the backend, all of them need not adhere to this HTTPS. So whenever we say SSL termination, like when we say HTTPS, each of those servers in the path needs to decrypt the information and encrypt. So they have this little overhead. So, and if you know load balancer is protecting to your incoming zone, like all your servers are within your own host or within your own network, you need not be worried about any request coming from load balancer, because we know it's already filtered out. So they can perform faster. So you'll have this HTTPS decryption and encryption based on the SSL certificates only at load balancer. And another interesting functionality is, like, they can also issue cookies and route requests, like in case if our backend servers are not handling the sessions. So at that time we can also use load balancer for maintaining the sessions. And when we say session, like the same user request go to the same node which has previously served this. Let's see, there are a lot of questions. Somebody said, are we adding a single point of failure? Yes, if you are configuring only one load balancer, because if that load balancer itself dies, then you have no means of accessing your website. So the general idea is that you have kind of at least master slave, like one load balancer acting primarily, one could be a slave watching, and if something happens with the main load balancer, the passive one takes up and kicks in. So if you have only one load balancer, that itself could be a single point of failure. So
could we use load balancers for routing region-specific traffic?
To region-specific traffic? So depends on for the region-specific traffic. So how do you identify the region? Is it like by IPs or it depends?
So load balancers are generally fairly simplistic and dumb. So they generally are not in a position to identify any parameter. Like they wouldn't be able to figure out whether the IP address of they would not be able to route traffic based on IP address or something else. I mean that is typically better handled by either the reverse proxy, which is the next one that I think Naga was planning to cover, or CDNs are in a much better
CDNs are most better. Yeah, correct.
And so you could also have domain name responders which are actually regional, which is what CDNs use anyways at the top of it. So there are a few other ways to do it. Load balancers actually selecting where it needs to go to typically is not something that I have seen in most cases. Like the way load balancers choose to send traffic downstream is primarily based on either they just randomly do it or they figure out which one's the most efficient one to send things to and which one's not busy or something like that. And the last one, of course, is it actually tries to send the same person to the same place. So that way you use like some sort of like stickiness with sessions or cookies or something, so that the same customer goes towards the same cluster of downstream nodes or something like that. So besides that, I've not really seen a whole lot of smarts or intelligence within the load balancer.
Yeah, so yeah, to answer, like in summary, it's not efficient for region-based directions. We might want to explore CDNs because they also support dynamic content now with the way I think the pull strategy. So it also supports a dynamic content. So that could be one way where we want to explore all the region-based solution. And regarding the IP address, it would be possible even in load balancer, just to add on Vivek. So that's what we are saying when we say a layer 4 here. I will cover that in the next slide. How do load balancer handle request going to a bad server? So this load balancers would, since they're talking to the servers, they know whether they're responding or not, right, based on heartbeat. If bad server or some server is down, it knows that it's not responding. So it would eliminate that node itself from being the list of in the pool nodes that it has to route. We can configure load balancer such that if it doesn't receive a heartbeat for 1 or 2 times, you can consider that as down. So we can have that configuration done in load balancer and identify this bad request, like it didn't respond for the 3 times, I consider that down unless it comes back to me with an additional acknowledgement or heartbeat that I'm back up or something. So I hope that answers the question. So as I was, to avoid failures, so it's common to set up multiple load balancers. As I was talking about, if you have a single load balancer, that becomes single point of failure. So you normally follow active-active or active-passive strategies, which I have talked in the previous slides. So since I said like it can route traffic based on this random least loaded server session or cookies, which we are familiar with, and round robin also we know, like the normal round robin, it actually simply goes every request from 1 2 3 4 again 1 2 3 4, like it keeps routing to the same order. But when we say weighted, it has some strategy to weigh on, like though it's round robin, It considers if it's already has some load, then it chooses the next one in the loop. So some of the two important load balancers, which are like layer 4 and layer 7, and I will say, I mean, like why they're called layer 4 and layer 7 here. So I hope like most of you might have studied computer science. If so, you would come across this concept called open systems interconnected model, which is a network layer depicting from the application session. So I will even touch upon that. So let's see that before. If it's in person, I would have asked some people to come up with to guess what layer 4 or 7 was. But considering the time, let's jump into the next slide. So yeah, so the OSI layer which I was talking about, like which comes in your networks if you have studied computer science, is basically a 7-layered protocol on which general communication is being handled over the internet. So the first one is the physical real like the cables where the data is transmitted. Next one is data link, which hands the data like from one MAC address to another MAC address. So they handle the data in the form of frames. The physical one handles in the form of binary bits, 0 and 1s. This one handles in the form of frames, and it delivers if you give one data from like one MAC address to another MAC address, that's what data link does. So this network layer is where our IP protocol fits in. So it's like IP address to IP address. So if all the routers which comes in the network, they fall under this, and they handle the data in the form of packets. And we have this layer 4, which is the transport protocol. It's a TCP. We all know, I hope most of us know what the TCP is. Like it's a reliable protocol which even our HTTP uses for communication over the internet. And it handles again in the data in the form of packets, but it has some reliability assurance, and it has traffic control. It assures that the data is sent in the same manner in which it received, so the sequentially. And there is this 3 layers actually. The first top 3, like the 5, 6, 7, sit in the end client and the destination, and session manages the session establishment and termination. So it's and the presentation handles all the compression, like compression techniques, like if you want to compress the data, or if you are encrypting or decrypting, that's where it takes. And application layer is where our end application runs. And I mean, like if in the internet world, it's typically HTTP. So that sits on the application layer and attempts to send the data. So this is a quick overview of OSI before I jump back to the load balancers. So when we say layer 4, so here it goes back to this transport layer. So it looks at the source and destination IP and ports, and this layer 4 load balancer looks at the information on source, destination IPs, and it does like based on the IPs, it transforms to the destination IP, it transforms to the respective server down the path. It also performs this NAT, network address translation. So I don't know if many of you know about what it is. Like I just want to refresh this also. When we say network address translation, like when the request comes to this transport layer, which is this TCP, so what it contains is the destination as its load balancer IP. And since the load balancer wants to forward this request to another node down the network, which is our web server or application or database server, so it changes the target or destination IP to that next node in the place. And when it receives the response, similarly, it removes that source IP as the load balancer IP. So that's a general meaning of when we say NAT, network address translation. So this layer 4, in summary, it looks at the information in transport layer and attempts to do the load balancing, like route the request. When we say layer 7, it looks into the application layer, and as I said, like when I say application layer, it's HTTP. If you take HTTP, it's like header message, like the message is a body, so it can intercept any of your request parameters. When I said it falls under this layer 7, so it can interpret any of the header or body request parameters that user is submitting, and based on that, like based on the user ID or like user last name, like it could be any information, like you can route the information accordingly. So just to compare layer 4 versus layer 7, layer 4 requires less computing resources because it hardly passes any small packet as such, and but whereas if you see the layer 7, you are passing the entire payload for some request parameters or the header, so it needs a little bit more resources. So any questions so far? I hope no. So let's continue.
Yeah, I have one question. I'm curious about how sticky session and cookies are maintained by the load balancer. Can you shed a light on how they store it? Like, is it in memory? Is it on a disk? And how is it communicated back and forth the client and the load balancer? Can you explain a bit about it?
Cookies is basically in the, it will be set in the HTTP headers, I assume, like somewhere. So it comes in the request, and I think this has specialized some, like when we say session or cookies, it's somewhere in the communicated through the HTTP header, and the load balancer can look at the information. And when I say the, I don't know, I'm just trying to recollect between a normal session and a sticky session. I think sticky session is something, the strategy is like the load balancer tries to forward the same user request to the same target server. This scenario I was talking like in the case of only when our backend servers are not handling the user sessions. Only in those cases we want our load balancers to handle these sessions. So that could be based on like some of the key parameters in our HTTP headers. That's what I assume. It could be the parameters identifying the session or the cookies, based on which load balancer knows that it is from the same user, and it redirects to the same target server as before. I don't know if I try to answer your question.
Yeah, I think it did clarify. So basically, if you are load balancing using sticky session cookies, so that's an application layer 7 approach to.
Yes, correct. Right? Layer 7. That's right.
Right, and cookies are generally handled on the browser, like but session is generally on the server, right? Stored on the server.
Yes, it will be stored on the server and it will be transmitted over the header.
Okay, so it's stored on the load balancer. All right, thank you.
You do want to distinguish between the server that the session that like a an application server maintains on its side, which is typically connected through cookies, and the OSI level 5 session, right? That's different. The layer 5 is different from the session.
Oh, layer 4.
Talk about.
Oh, yeah. This layer 5 is different from this. Yeah, this is for the communication layer 5. Yeah, correct.
Correct. That's a different protocol. So if you look at things like network file systems or other protocols, that is a different thing than cookies, because cookie information is actually at a much higher level, right? It is actually after protocol. So it actually, once you figure out that it's HTTP or HTTPS or whatever, and then the cookie information is just a part of the headers of that particular thing. So it's a little much higher. So essentially, it's an application layer.
Okay.
If you're using cookies for session, then you're already at the application layer. I don't think you're not at the. This is not the session alone, which is on layer 5. I don't know if that made sense. Hey, quick thing, Naga. We have about 15 minutes, so why don't you just complete the load balancer, and then we will take more questions, and then we'll stop with that.
Yes.
You have one more slide,
okay.
Right?
Let me see. Yeah, I just have one more slide. So I just wanted to add on something to which Ram was asking. So if you want to, this is generally general practice that our application or web servers handle the sessions in a Redis or Memcached or even in another database. So the same could be, the same strategy could also be worked out with a load balancer, where load balancer could look up into this database for session management if none of our servers are ready to handle the sessions. So hope that answers. So let's go back to this next slide. So this load balancer normally help in getting your system horizontally scaled, so which is more ideal than the vertical scaling. So it improves the performance and availability of your system. And some of the disadvantages that you see with this is like each of the servers should be stateless. That means they should not have any user information, and sessions need to be maintained in one of the centralized data store. One of the example is like Redis and Memcached, as I talked about. So yeah, in general summary, like the disadvantages of the load balancer is it should not become a single point of failure. So that means that you need to configure at least like couple or more, which increases the complexity. So if you don't configure the load balancer properly, then it could become the performance bottleneck, or like behind the load balancer if you don't have enough resources. Yeah, I think with this we can conclude the load balancer. I don't know, I have a lot more slides, I think, but we are short of time. I think
we've got about 15 minutes, so let's actually just handle some more questions. Anybody with any questions on whatever we have covered so far? Yes, Sanjeev, I will be uploading the recording after this. So it should be up in like an hour or so after this.
I think I have, I don't know, like if we want to do this as like the remaining in the another online session, or do we want to cover this in person? Like Vivek, what would you suggest?
I think we'll just use one of the other online sessions to cover it, given that there's a bunch of folks who kind of teased them with this session. So I'd like to do the part 2 online as well. It may be in a couple of weeks, not immediately, but that will be a good good plan. Thank you everyone for actually attending. I think we've got like 40, 50 people at some point of time now. I think I've got 48 folks online. So this is good. Any more questions?
instead of waiting for a couple of weeks, I mean, if every folks are okay, why don't we, since it's an online, nobody is, I mean, the barrier is less to attend this session. Why can't we have sooner? Is that possible? Or because by the time we wait for 3 weeks,
Yeah, I think he may be right, Vivek. It's good to have sooner because people might will be in touch now.
Right.
So I don't know, they can quickly get onto the speed.
Let me turn off the recording, and then we can just, if there's no more questions specifically on the session and just about follow-ups, let me turn off the recording.